Hello all, welcome to my channel. In this video, we will be continuing the iceberg series that we are doing. And in this video, we will be looking at some of the updates that has come in the iceberg v3 spec. So let's get started. So what is, first of all, what is iceberg v3? So v3 is a spec, which is the version 3 of iceberg. So iceberg has gone to previous version upgrades, Iceberg version 1 and version 2. So in version 3, the major updates are these like deletion vector, then variant data type, row lineage, and geospatial data type. So we will discuss this all, what each of them mean and why those are important. So first of all, now now iceberg has an previously iceberg has a very big challenge when it comes to doing a row level delete. So how previously the row level deletes were happening is if we are using merge on write, copy on write or merge on read. So in copy on write, if we did a delete, the whole file was getting rewritten. But if we're using merge on read, so we were creating two different file types like positional delete and delete delete by key. So equality delete. So those two files which we were storing separately, but again over time it was getting complex to maintain that or to do compaction because we will have if we have frequent deletions happening, it was very challenging to maintain that. So what this Iceberg v3 spec introduce is a binary deletion vector. So it is a new performant and a scalable solution for deletion. So the core idea here is that we attach a bitmap to each of the data file, and each bit in the corresponding row, means each bit in that bitmap corresponds to a row, and there is a vector saying that okay, whether this is deleted or this is not deleted. So if a bit is set, then that row while reading that data file will be considered as deleted. So that's what happens. So when a query engine reads the data file, it also reads the corresponding deletion vector. As it scans the rows, it can check the bitmap and see if the minimal overhead, it can check with minimal overhead that which rows are to be skipped because they are marked for deletion. The design is made, this is efficient because it uses roaring bitmaps, which is a very optimized format to use to store binary vectors. And because it's also is it compresses the sparse set of integers because we will have either 1 or 0 for the rows, right? So it is very useful for those scenarios because if we have sparse set of integers like positional delete or deleted rows, so it will create a very uh, tiny memory footprint. So the overhead of opening that file or opening that vector is very small. And the difference between the V2 and V3 is that in the previous models, we had positional deletes or equality delete. So where we had deletes the tab row file and then file path and row position was mentioned. But in V3, we use deletion vectors where each data file has an small efficient sidecar file, which is puffins. And in that, not in that, but that puffin file simply has the bitmap of the deleted rows. So this what it does it that because we are storing the file a data file and its deletion vector in the same file. So if we have to delete a certain file or certain row, we have localized that update operation or delete operation to that particular file itself. So we don't have to do multi-file juggling to find out which file is deleted. And also we can do CDC as well or row level updates using this because role update is nothing but uh, delete plus insert in Iceberg. So that is something we can do very well with this deletion vector. And also in V3 which is the V3 spec. Position delete files are getting replaced with highly performant Puffin files, and Puffin file has been pre-purposed for storing deletion files as well. So each file will get its own deletion vector. So this is proposed in the V3. Not V3 proposed, it's already there. Now comes the other change that has happened, which is something related to schema evolution. So earlier, what if used to happen that if let's say we have added a new column in Iceberg, and the older data files doesn't have that. So we used to generally do a backfill to update those previous files, and that was very time consuming because we have to touch every file which was being accessed or which didn't have that column. So to provide a default value into that, we need that uh, backfilling operation, which is very expensive. So what Iceberg v3 does, it's that eliminates that friction because it allows us to have delete column values, default column values. So what it does, it so when, let's say, if we have changed the schema of a particular table and we add, now we provide a default value. So what happens is while the operation, like this operation, like alter table, add column name and provide a default value. This is a metadata change. This is not happening at the file level. This is just a metadata update. And while we are reading, so whenever a query engine encounters an older data file without a column which is added later on, so it will just consult the table metadata or schema and find the default value, and at the runtime it will add that value. So the files are not getting touched at all. So older files will have its own schema, but when we combine with this new schema we have, then we will see that the default values are all calculated on the fly and they are available. So this makes schema evaluation very fast, non-disruptive. Then we have row level lineage. So this is done for auditing purposes like in CDC pipeline. So V3 has a formalized tracking of row history. So every row will have a lineage now. So the embedding, the metadata of about this row lineage will be embedded into the metadata as and when they are getting modified. So now the iceberg tables can provide a clear lineage based on the row, and we can also simplify this by like simply it will simplify the data governance and uh, data replications as well. Because we know the lineage, so we can recalculate it as well. So this is something that, and then we have enhanced data types. So enhanced data type, when I say, it means we have three new actually data types which are added in the V3 spec. One is variant, which is a semi-structured data like JSON, and but it is faster than JSON because it has binary representation, plus it has concepts of threading, and it can support also arbitrary number of what's called nesting. So this is very flexible in terms of schema. And we also have in V3 geometry and geography type. So this is something which is interesting for people who are doing spatial analytics. So spatial analytics requires certain specific data types which are as of now not supported. So once this iceberg starts to support this, we can unify the normal data, tabular data analysis with the spatial data analytics and combine them together. So that is what this geometry and geography data type will bring. And Iceberg also added support for nanosecond precision timestamps. Earlier it was only till microsecond, now it supports till nanosecond. So if we have something which is very a data type, if we have high precision requirement, then yes, this data type helps in there. And there are some other changes as well, which is not, I will not say it is part of V3, it is part of the new release of Iceberg that has come up, like 1.10. So in this, we will have support for Flink 2.0. It also supports Spark 4.0. It has added a new Spark action to compute partition stats with incremental computation, and we also have max files to rewrite, which says that the scope of the compaction jobs can be configured now. So in a particular rewrite, how many maximum number of files will be rewritten in one go. So that is what it will do. So these were the some of the major updates of the Iceberg v3. So if you like this content, do share it and watch the other videos on this playlist, which is for Iceberg. Have a nice day. Thank you.